Hello students, welcome back. Previously we went through sections 1 and 2. Now let's go to section 3, arithmetic rules of real numbers. But before starting section 3, some review is in order, especially subsection 2.1, the algebraic properties of real numbers, and please stop the playback and read through if necessary. Please remind yourselves about associativity, commutativity, distributivity, identity, inverse, those kind of things. All right. Okay, now let's go to section 3. And the very first topic is how to define subtraction and division. Basically, the subtraction is adding the additive inverse. You see, this subtraction by b, which I'm highlighting in red, is actually adding negative b. So this negative sign is actually part of the next number. The same goes for multiplication. Division is nothing more than multiplying the reciprocal, the multiplicative inverse. So this division symbol, or some people write like this with slash, that is actually the part of the next number. As a matter of fact, if you write like this, then whether it's part of the next number is actually crystal clear. It was a bit less clear if we had this division symbol. So few people get confused here, but I see a bit more confusion over here. So whenever you see a negative sign with addition or subtraction, do not consider subtraction as a separate operation, but consider it as a part of addition, just adding the negative number. And whenever you see a negative sign, consider it as a part of the next number. Let's see, here's an example. 3 plus 7 minus 9 plus 2 minus 3. Okay, all right. For example, if you have to do this kind of computation, and this is actually the same as 3 minus 3 plus 7 plus 2 minus 9, kind of like this. You see, this negative 9, which I just highlighted in red, and this negative 9, they're just addition, so I can change the order. You see, subtraction may not be commutative. A minus b is not equal to b minus a. So you have an illusion that subtraction may not be commutative, but no, as a matter of fact, addition is commutative, and subtraction is nothing more than just adding a negative number. So I can change the order using the commutativity of the addition. Same here, this blue, that blue. I can change the order because we are talking about addition here. So what do you have? 3 minus 3 is 0. And then 7 plus 2, that's 9. Minus 9 is 0. So we do this kind of computation. I can change the order freely. Just take the sign with you. All right. What's the next topic? Properties of 0. Okay. Addition by 0, no change there. That's because 0 is the additive identity. We already saw that in section 2. Multiplication by 0, that's a bit strange. And multiplying by 0, you always get 0 no matter what. And we can actually rigorously prove it, but this is Math 1324, so I'm not going to do that over there. And we'll probably prove it. Good question. When do we actually do that? Probably in some 2000, maybe 3000 level course. So if you're not majoring in mathematics, you won't have to worry too much about proof of something simple like this. Same goes over there as well. Zero product property or zero divisor property. X times y is 0, then either x is 0 or y is 0. There's no way we are going to get 0 by multiplying two non-zero numbers. 0 over x, that's okay. 0 divided 14 is 0. 0 divided by 2 is 0. 0 divided by square root of 17 is 0. It's all okay. But if the denominator is 0, then that's undefined. Even 0 over 0 is undefined. So denominator cannot be 0. But numerator, that's okay because this thing is, as a matter of fact, 0 times 1 over x. And 0 times something is always x, you see. Whenever 1 over x is well defined, this expression is totally fine. This expression, on the other hand, is not fine. So no denominator, 0, but numerator 0, that's okay. Here's some properties of 1. Multiplying by 1 is okay, all right. Multiplicative identity, fine. And if you divide by the same thing, then that's 1. But remember, x should not be 0. 0 over 0 is not well defined. Let's see, what other properties? Okay, properties of sign. Positive times negative is negative. Negative times positive is negative. Negative times negative is positive. Some people get confused right here. So double negative, negative times negative is positive. Here's one more. Negative and negative again, we get positive. Similar thing works for division as well. So if you have two opposite signs, negative, two identical signs, that's positive. Positive times positive is positive. Nobody gets confused with that, but negative times negative becoming positive, sometimes people get confused with that. Remember all those. And as for the proofs, this is 1324, so I'm not going to prove any of those. Just remember those as properties. And if you're interested in the proofs, well, please let me know. I'll give you some links that deal with the proofs, but be careful there. If you're really interested in going through the proofs of all those properties, you're walking into some serious mathematics. So if you think if you're not up to it, then don't do it. And if you feel interested, okay, go ahead and explore. I'll be really happy to help you out. Okay, so much for section 3, and we're going to deal with section 4 and section 5 in separate videos. Let's stop here.